4.5 graphs of sine and cosine. So what we're going to do is we're going to take our unit circle, basically, and we're going to put it on a Cartesian plane. All right? So I want you to think of your unit circle. You got it? All right. So the first thing we're going to do is graph sine. So think of your unit circle. What is the sine of 0? 0, right? So sine of 0 is 0. That's why it's there. And then we're going to do pi over 2. So what's the sine of pi over 2? Think of your unit circle. What do we get? The sine is the y. So it's what? It's 1. So that's why it goes up to 1 there. And then what's the sine of pi? 0. So it goes back to 0. See how that worked? And then what's the sine of 3 pi over 2? That's why it goes down there. And then what's the sine of 2 pi? 0. So it goes back there. And then it's going to keep doing the same thing. It's going to keep going wave after wave. It slowly drifts. However, it does the same thing because its period is 2 pi. That's how far it completes its cycle, or its wave in this case. All right? Does that make sense? Because of coterminal angle, remember it goes back again to the same thingy? All right? So that's why they work. All right, let's talk about cosine now. All right, hopefully you're sketching this little guy out. All right, what's cosine? What is cosine of 0? 1, because the x value is 1 at 0. Make sense? All right, so now we start out at 1. And then what's the cosine of pi over 2? It's 0, because the x value is 0. Remember? All right, and then what's the cosine of pi? -1. That's why it goes down. And then what's the cosine of 3 pi over 2? 0. And then what's the cosine of 2 pi? 1. All right? And so that's the and then it's going to keep on going, wave after wave, slowly drifting, same thing. All right? Where does sine start?
The origin?
I don't want to say the origin.
0?
It does. It starts at 0. All right? It starts at 0. And then where does cosine start?
1.
At 1. And this is the basic function of sine and cosine. Does this make sense? All right? Yeah. The actual difference, if I were to take cosine and I'd move it over a little bit, do you know what would happen?
It would turn into sine?
It would turn into sine. If I actually shift cosine pi over 2 to the right, guess what it actually is? It's actually sine. If I take sine and I move it back, if I move it left pi over 2, guess what it would be? It would be cosine. That's the only difference between them. All right? So, actually, the only difference between sine and cosine, yeah, you think of it as y and you think of it as x, but it's really a shift of pi over 2. That's really what the difference is. All right? Cool. All right, let's sketch some things. So now we're going to sketch y equals 2 sine x. And I'm going to do it on the interval 0 to 2 pi. All right? All right, so I need you to think of your unit circle. You got it in there? Awesome. So what is the sine of 0? 0. So 0 times 2 is 0. So that thing starts out at 0, remember? All right, and then let's go to pi over 2. So what's the sine of pi over 2? 1. And then I do 1 times 2, which is 2. So it goes up to 2. All right. All right, and then let's do pi. So what's the sine of pi? 0. 0 times 2 is 0. So it goes back to 0. And then at 3 pi over 2, what's the sine of 3 pi over 2? -1. And then we multiply it by 2 and we get what? -2. And then we substitute in 2 pi. So what's the sine of 2 pi? 0. 2 times 0 is still what? 0. And so now I can kind of connect the little dots in a smooth fashion. And there we have sine. What was different than the one we talked about on that first page to this page?
It's taller.
It's taller. I like that. Does anybody know the word? All right, that is the definition of amplitude. And we need a reader. Thank you so much, Christian, for volunteering. I appreciate it.
The definition of amplitude of y equals a sine x and y equals a cosine x represents half the distance between the maximum and minimum values of the function and is given by amplitude equals a...
The absolute value of a. All right, so the amplitude is the coefficient in front of the sine and cosine. All right. However, it's the absolute value of that, and we'll talk about that, why it's the absolute value and not just that number in a sec. All right. Now, the pure definition is half the distance between the top and the bottom of your function. I always think about it as the distance between the centered of the function to the top or the center to the bottom. That's the way I think about it. It's the same thing. It's just, that's the way I think about it if you want. All right. All right. So we're going to sketch some graphs of these guys now. All right. So we have 1/2 cosine x now. We have 1/2 cosine x. And we're going to graph this guy, and let's say it's red. Let's say this one's the red one. All right. So let's think of unit circle. We got it? All right. Let's do cosine 0. What's cosine 0? 1. But I need to multiply it by what? 1/2. So I get 1/2. Make sense? All right. Cosine of pi over 2. 0. All right. Then cosine of pi. What do we get? -1. But then we multiply it by 1/2, and I get what? -1/2. And then we got 3 pi over 2. What's the cosine of 3 pi over 2? 0. And then 2 pi. I get 1, so I get what? 1/2. All right. And so now I have that going on right there. So when we look at this guy, where does cosine normally start? It starts at 1 normally, right? And then it goes down, and then it goes to the minimum, basically, and then it goes back to 0, and then it goes back up to 1, right? In this one, we had to deal with its amplitude. Well, what was the amplitude there? The amplitude is 1/2, all right? And so instead of starting at 1, where did this thing start? 1/2, and then it went all the way down to what? -1/2. I know it looks like it went further, but that's my bad drawing. All right, makes good? All right. All right, I'm going to change this one up a little bit. I want to call this one y equals -3 cosine. All right? All right, so now I got y equals -3 cosine x. All right, you got cosine in your head? Cool. So what's the cosine of 0? 1. But I need to multiply it with what? What do I get? Love it. All right. And then pi over 2. What's the cosine of pi over 2? 0. -3 times 0 is still what? 0. All right. And then pi. What's the cosine of pi? -1. But now I have a -3 times -1, which is what? 3. All right. You see how knowing this unit circle is kind of helpful? It's going to keep coming up. All right. And then 3 pi over 2. So what's the cosine of 3 pi over 2? 0. So then it goes back to 0. And then at 2 pi, what's the cosine of 2 pi? 1. And so 1 times -3 is -3. And so when I sketch this guy out, it's kind of like that. All right. And then it's going to keep doing that wave after wave. All right. Every 2 pi, it does that. All right. Now, what's the amplitude on this thing? 3. The amplitude is 3. But yo, Mr. Flick, it's not negative. Why did it start out at -3? Where does cosine normally start? It flipped over the x. Why did it flip over the x, guys?
It's a negative.
Because it's negative. It changed its y value, so it flips over the x. However, the center to my max or my min is still 3. Okay, it's a positive distance 3. Make sense? All right, cool. We're moving. All right, let's start talking about some periods now. All right, we're talking about periods. All right, I need a reader. Christian, pick somebody.
Let B be a positive real number. The period of y equals a sine bx and y equals a cosine bx is given by a period equals 2 pi over 2.
All right, fantastic. So what's the normal period of sine and cosine?
2 pi.
2 pi. It usually completes its cycle in 2 pi. Yeah?
Mm-hmm.
All right. Well, now it doesn't always have to be that way. Okay? If we have a coefficient other than 1 in front of this x value, the period has changed. All right? It's going to complete its cycle like it's going to take longer, or it's going to be shorter. Okay? If that's not 1. All right? And what we do is we divide 2 pi by that coefficient. All right? Does that make sense? All right, cool. So let's look at this first example. So we got y is equal to sine of x over 2. All right. Let's find out its period. If we can figure out periods, we kind of know a lot about this function. All right, so what's my normal period? 2 pi. And I'm going to divide it by its coefficient of x. What is the coefficient of x here? 1/2. All right. Some people have trouble with that. This is the same thing as saying 1/2 x is x over 2. You know, those are the samesies. All right. Some people can't see it very well. I don't know. All right. So now we have divided by 1/2. Well, when we divide by a fraction, what would I suggest you do? You multiply by its reciprocal. So instead of dividing by 1/2, I'm really doing what? Multiplying by 2. So what's my period? 4 pi. So this function of sine of x over 2 is actually going to complete its cycle in 4 pi. All right? So a normal one completes it in 2 pi. But now this one's going to complete its cycle in 4 pi. And if we truly understand what sine does, where it starts and where is it going to finish, we can graph this pretty quickly. All right? You think we can? Where does sine start? 0. Sine starts at 0. Does everybody agree? So where's it going to end? At 0. Yeah? In the middle, what's it going to do? It's going to be 0. What does sine normally do? It starts going which way? Up. Well, what's the amplitude of this guy? 1. So it's going to go to 1. And then it'd go below to -1. And so now we have a sketch like that. All right? Pretty easy. If you can do its periods, you don't have to keep substituting in. All right? All right, we're going to do another one. I want to do sine of 2x now. Y is equal to sine of 2x. And if we can truly understand its periods, we can do this pretty quickly. All right, so let's find out its new period. What's my normal period? 2 pi. And I'm going to divide it by what? What's the coefficient of x? 2. So now this sine function is going to complete its cycle in what? In just pi. It's going to complete its cycle in pi. All right? So where does sine start? 0. Where's this one going to finish? At pi. Now, where also is it going to cross? Pi over 2. All right? Because it's going to cross in the halfway point. Does that make sense? All right? And so where's it going to have its maximum? Where's it going to go up to 1 at? Pi over 4. It's gonna go up at pi over 4. It's going to go back down at pi over 2. And then where's it going to have its min at? 3 pi over 4. All right? Because we're splitting them up into fourths. All right? All right, now we're going to talk about transformations. Okay, and transformations we've been doing since chapter 1. We're going to continue to do them. If it's inside, no, just kidding, outside, inside first. Inside I got on there. If it's inside my function, which way does it move? Left and right. Okay? If it adds something, it really does what?
Left.
It goes left. If it's subtracting something, it really goes what?
Right.
Right. Now, if it's outside of my function, what does it do? It goes up and down. If it adds something, which way does it go?
Up.
If it subtracts something, it goes down. All right. All right. So now we end up having a function with more on it than just a sine bx. Now we have a sine bx minus or plus c. All right. And so the amplitude is still the absolute value of the coefficient in front. The period is still the coefficient with your x. But we need to figure out where they move, left and right. And so what my students like to do is they like to set it equal to 0. This is probably the way my students like to do it. Because where are the endpoints of sine? 0 and 2 pi. All right? Those are usually the endpoints. Now, if I have cosine at 0, they usually start where? At 1. And then at 2 pi, it usually ends up at 1 again, right? However, the normal period is 2 pi. Does that make sense? Yeah. So that's why we're setting them equal to 0 and 2 pi. All right? We're moving. Here we go. All right, so let's do this first function. So I have y equals 1/2 sine of x minus pi over 3. This is likely how I'm going, it's not likely, it's going to be. This is how I'm going to assess you on this stuff. All right? I am not going to have you graph on a test. Does everybody hear me? Yes. I am not going to have you graph on a test on these kind of problems. Okay? Now, could I give you a graph and ask things about it? Yeah. Yes. All right? But if I just give you a function, am I going to ask you to graph it? No. I'm telling you right now, I'm not. Okay? But we need to kind of understand things about the graph in order to do some stuff. All right? Sound good? So we're going to talk about amplitude, periods, and shifts. So this first one, what's my amplitude? 1/2. Pretty easy. All right. Period. What's my normal period? 2 pi. What am I going to take 2 pi and divide it by? 1. Because I got 1 right there. All right. And so what's my period of this guy? 2 pi. Now, shifts. What's it doing?
To the right.
It goes to the right what? Pi over 3. I want to go further on this. Okay? Sometimes students just like to set that junk equal to 0. We've kind of talked about this in the past. If you set that inside function equal to 0, you're going to get x is equal to pi over 3, right? Is that positive or negative? Positive. That's positive. That's why it moves to the right, pi over 3. Does that make sense? All right, cool. Let's look at this next one. This is probably close to how hard it might be. All right, so we got y equals negative 3 cosine of the quantity of 2 pi x plus 4 pi. Got it down? All right. What's its amplitude?
3.
What's the amplitude?
3.
3. What's the negative do?
Flips it.
Good. What's it do?
Flips over the x-axis.
And that's a what? Is that my amplitude or is that a shift? That's a shift. So this is a reflection over what? The x-axis. All right, that's part of a shift is that negative part. Guess what students mess up sometimes on that thing? They tell me my amplitude's what? Negative 3. All right, the negative is the flip. All right, it's the reflection. All right, now let's talk about its period. What's its normal period? 2 pi. Well, what do I need to do? Divide it by 2 pi. That's the coefficient of my x. So 2 pi over 2 pi is 1. So this cosine function is going to complete its cycle in 1 unit. All right, instead of the 2 pi. All right, it's a little faster. All right, and then now let's talk about its shifts. All right, first of all, which way did this move? Left. But how much?
4 pi.
2. It moved left 2. All right. Now, this is the way most of my students like to do it. They like to set that equal to 0. All right. And I'm going to show you both ways. So you set it equal to 0, so then you get 2 pi x is equal to negative 4 pi. And then you do what? Divide by 2 pi, and I get x is equal to negative 2, which means it did what? Left how much? 2. Now, the way that I taught my Algebra 2 students as well as my pre-calc classes, I actually like to factor out this coefficient in front of x. I think I taught you this a little bit before with like absolute values and things too. All right. So I would convert this one to like negative 3 cosine, and then I factor out a 2 pi, and then what are you left with? X plus 2. And so now you can actually really see it right there. I like to factor it out. However, do I care honestly if you factor it or you set it equal to 0? Do I really care? No. As long as you can get to Tampa and say left 2, I'm good with it. Are we good? Mm-hmm. All right, cool. All right, let's look at this next one. I got 2 plus 3 cosine of 2x. What's its amplitude? 3. All right, what's its period?
Pi.
It's just pi. So I take a 2 pi and I divide it by what? 2. So I end up with pi. All right. And then shifts.
Up to.
What's it do?
Does that too?
It just goes up 2. Does it do anything else?
Nope.
Nope. And then we're done. All right. All right. There we go. There you go. All right. So on these two, those two are the only ones that I want you to graph. Okay? So on 31 and 33, I would like you to graph those. Okay? For 39 through 55, every other odd, by the way, that's only 5 problems. So it sounds like a lot more than 5, but that's only 5 problems. I want you to do amplitude, periods, and shifts. Okay? It's going to tell you to graph them on the book or the exercises. However, do I want you to graph them? No. I'm only having you graph 30, 31, and 33. Right?